Welcome to Geology, everybody. How we doing? So it's time to take a slightly difficult step in our tectonics journey here. You should have made it through the videos that talked about the outside of the Earth, lithosphere, stenosphere, and then another video for deeper in the Earth, getting into the cores and how we figured that out. Next thing we got to do is really get into this crunchy outer layer we have and think about why it's broken up into all these pieces. Now, one optional but very handy tool that I'm going to have is this Google Earth file right here called tectonic plate boundaries.kmz. That I'll put into the thing now, into the section of the class, the segment. Though I think the only way it's going to work, though, is if you download the actual software of Google Earth. There may be a way to download it into the browser version, but I really wasn't having much luck with it on a Chromebook earlier. If you've got access to a full computer and you can download this Google Earth software, then this pops up and it's pretty handy. If you can't, you can still get through this. And I'll be using this to show you what these are all about. But why it's really handy if you're studying on your own is they break it down by the types of faults. That's where we're going with this. What are the types of faults that are all over the place? San Andreas fault's like the one that people just know. The San Andreas transform plate boundary, we'll really call it. And you can see right here, see that kind of red color? And you can click it on and off if you it's tough to detect the differences between some of these colors. But anyway, it superimposes it right there on the surface of the Earth so you can see it. And you can see this little plate here and what's going on. And we'll be coming down here to South America to look at this one and what's going on. It just makes it a little bit easier. Without it, you can still see things. And if you don't have access to Google Earth, while I talk about all of these, I'll have it on. So you'll be able to see it there. So it's not a totally unfair advantage. So this is my hey buckle up video. It's going to get a little bit information dense for the next chunk of videos. The other thing I got that I recommend is I'm going to upload this as a PDF, but pretty much leave it up to you to fill out. I won't necessarily be filling this out through the videos. If you watch the videos, that should be fairly easy. And of course, email with any questions. I'd say easy to figure out, but it's a lot of information. That's where it'll be a little bit dense, which is why maybe using a note sheet is handy. We'll talk about each of these, and I think just to keep it from being an overwhelmingly long video, I'm going to just do separate short ones for each one of these. So this is like video 3. I'll number all the rest going down. I do recommend going in this order because there's things I'll talk about that then will relate to the next ones going down the list. The general categories, we've got divergence, convergence, and transform. So let's just throw that one out there right away. And then the subsequent videos will break down exactly what goes on with these. So what's going on in divergent? Things diverge without knowledge of geology. That's a general vocab word. Things diverge when they spread apart, right? So the type of stress on this, we call that tension. This is going to be when the crust is being yanked apart. So let's check that in there. It's kind of an oddly shaped box, but TENSION. That's terrible writing, but tension. All right, that's both divergence. That's why I merged these cells here are going to be when there's tension being pulled on the crust. Convergent, that's when the crust is being compressed. Let's use a text box instead. Compression. It'll let me turn it. There we go. Compression. All right. That's when the crust is being squished, right? These terms hopefully make sense. Now, transform, what I'm going to say here is shear. This is going to be when one is going one way and one is going the other way and they're sliding past each other. There'd be like a shear stress. Okay. What kind of faults do these lead to? Now, I think what I'm going to do now, so that we don't get overwhelmed, because again, this is already going to be a lot, I'm going to throw the names at you. Before tectonics is over, we'll look at some of these with drawings. I'm almost tempted just to skip it, but let's throw the names out there anyway. When there's tension, when the crust is being yanked on, these are called normal faults. More to come on that soon. When there's compression, when it's being squished, these are called reverse faults. Thrust faults can be a part of that too. And when these happen, It's called transform, the biggest word for the smallest box. Sorry about that. Use a smaller font. And that's going to be, again, where they slide past each other. So that'd be the types of faults that we would expect to find. Now, those will be like inherent in all the drawings we do for all of these and all the chatting we do about all these. But we'll get a little bit more specific on those before the unit is up. Okay. So my plan is, again, I'm going to go through each one of these. If you're a notes person, you're going to want to try to fill this out and figure it out as you go. I just put a blank page here, and you might want to use your own paper or add more pages to your PDF. I'm going to be doing a bunch of drawing to say, okay, when you get a divergent boundary, here's what it looks like from the side. When you get a convergent boundary, oceanic continental, here's what it looks like from the side. We're going to draw them all out. We'll look at them all on Google Earth, and we'll try to pull it all together. It's going to be a slightly information dense section of class, as mentioned, but you can do it. You'll do a great job. Okay, so hold on to that for the next 1, 2, 3, 4, 5, 6 videos. And they'll all be posted soon. We'll get this thing moving. All right, sound good, everybody? Good luck on it.